flame. Our last part talks about flame. What all do we have? That's flame and structure of flame. That's one question that comes, and harmful effects of burning. Chalo. So we talk about flame. Are we ready? All of you? Okay. Now, you must be noticing that when you burn substances and they undergo combustion, you have certain things. Have a pen. This is not, keep your copy open and take a pen. It's a class. You cannot sit like listening to a story. So, right. So, as we are talking about combustion and things burn. Now, have you seen there are two types of burning that will take place? Suppose I have a substance and this substance is combustible. So what type of substance I'm having? I'm having a combustible substance. Combustible substance. And for this, I'm taking two types of examples. I have coal and I also have, say, something called diesel or kerosene or diesel, right? What you'll find is that when you burn both of them, then you will see a difference, okay? The difference is if you ignite diesel, then you will see flames. Right? And if when you ignite coal, you don't see flames. Coal does not give you flame, but coal will give you what is known as a glow. So we need to understand what is the difference between a flame and what is the difference between a glow. Are we fine? Okay. Now, when you have a combustible substance, obviously, when you are undergoing combustion, okay, when we are undergoing combustion, then one thing is evident that we are supplying heat to it. Otherwise, the combustion is not possible, right? Now, if upon supplying heat, you expect the fuels, some portion to vaporize. Do you understand vaporize? The fuel changes its state. Like say diesel, I'm heating it. So diesel is liquid. The next state that it will take up is the gaseous state, right? So if I'm heating a combustible substance when I'm undergoing the process of combustion, question arises, does this fuel or does any fuel will always, will be undergoing combustion. Does this substance vaporize or not? I'm asking a question now. Does it vaporize or not? So the answer will be that yes, some things vaporize, and its vaporize means only a portion, not everything, only a portion. Some things vaporize and some do not. Understood? So the things which vaporize, they will always burn with a flame. Let's take a small example. For example, we have our birthday candle, right? And if you have the wick, you'll see that there is a flame on the birthday candle. What is happening in this case? The candle is made up of what? Wax. In other sense, we call it as paraffin. P-A-R-A-F-F-I-N, paraffin. What is the state of paraffin out here? Solid. Then you will find a zone. You will find a zone when you're heating candle. Have you experienced this? You're taking a lighted candle and some hot wax falls on your hand. Some momentary hotness you feel. After that, it peels off like a beautiful skin. Have you seen that? So in this portion, you will see what? In this portion, I will be seeing the liquid version of paraffin, right? Here it was solid. Here it is liquid. Now, once it gets heated through the wick, now what is happening in the wick? The wick is also getting coated with liquid paraffin as the paraffin is burning, right? Then what happens in this zone, paraffin has become gaseous. It's a gas. Fuels which have a gaseous zone on combustion, only there you will see flame. Yes, samajh mein aaya? Lekin in the case of coal, right? Like sometimes, your name was Charvik, right? Sometimes I do change over to Hindi because it comes natural to me. If you have not understood, it will be your responsibility to stop me and tell, sir, I did not understand. Do you get that point? Do not hesitate. Like if they don't see, look at him. He did not understand or he had some doubt. He openly asked me. So I cannot come and ask you, you stop the vehicle then and there. I don't get angry at all. If you think that you have spoken something in some language you have not understood, you please speak up. Sir, I did not get that line. But slowly in the way, you will also pick up a language slowly. That's not an issue because anyway you have it. Everyone learns every language. I speak in Telugu also. Don't worry. So if you have a fuel which has a zone of vaporization, only then in that fuel we will see flame. In the case of coal, no matter how much you heat it, you don't get a zone of vaporization. We initially might get some coal, immediately might catch up some sort of a flame. Have you seen agarbatti, the incense sticks that we use? Instantly there will be a flame. After that, the agarbatti's fueling is not that much. The fuel is not that much that it vaporizes. So what do we see in an agarbatti? We always see a glow. So have you understood the basic part of flame? Flame will always be associated when you burn a combustible substance. But the question that you need to ask yourself, is there a region of vaporization when that thing is burning? If there is a region of vaporization, yes, I will get flame. The best example is the LPG gas that you're using. When we turn on, suppose you go to your, not in Pebble City, you go to a relative's house, what do we use? We use that red cylinder. Have you seen? The red cylinder does not have gas inside it. I hope you know that. The red cylinder has got liquid inside it. And when you turn on the cylinder knob, the liquid slowly exposes out. And when it comes into the atmospheric pressure, it converts immediately into a gas. And flame catches. Right? So are we in a region, time to now, so we can write the definition of flame now. We are now in a position to write the definition of flame. So you write, the flame is a flame is the region where combustion of gaseous substances takes place. A flame, whenever you are seeing flame, that means that region, combustion of gaseous substances are taking place. Shall I write down for you? Come on, let's write it. So we're talking about flame. So what do we write? A flame is a region where combustion of gaseous substances takes place. So it makes your understanding now absolutely clear that if you see flame when you're burning something, that means there is gaseous substance in that place. Now, what is that gaseous substance? The same fuel that we took, it could have been in solid shape like wax, has got first heated to liquid, and then when further heat is generated due to the combustion, that fuel has converted its state from liquid to gas. Now ask a question to yourself. Let us talk about all gases. Does LPG catch flame? Yes. Will CNG catch flame? Yes. Right? Will hydrogen gas catch flame? Definitely it will catch flame. Any gaseous thing will catch flame. Then let us now come down and ask about liquids. Will kerosene catch flame? Well, kerosene is such a thing which is volatile. So now next word that you should understand, we'll write a new word called volatile. Volatile substance. What do you understand by volatile substance? A substance which vaporizes very quickly. Girls, you might be knowing, when you put that nail polish enamel and you want to remove that enamel, you use something called a nail polish remover. Have you seen that? A nail polish remover, we just open it, we dip cotton into it, and if you have kept it open, your mom will scold you because you are supposed to keep it closed. Either you press your thumb or you keep it closed. Why? Because the nail polish remover is highly volatile. It will vaporize immediately. You will be a super idiot if you take your scooter's fuel tank और खोल के रख देते हो, सब उड़ जाएगा. समझ में आ रहा है? अच्छा, इससे एक चीज और समझ में आया. We get to know one more thing. Yeah, but try to listen a bit, then only you will catch up. We get to see, if you stand away from one another, kunchum Hindi tells you, problem is not there. If you try to understand, then only you'll understand. Otherwise, your third subject you will not learn. So, when we are talking about a fuel which is vaporizing, it strikes our mind that when you burn this particular fuel, it will have flame in it. Think about petrol. Does it burn with a flame? Obviously. The recent air crash and all, if you see. So all of flames came up. Why? Because it was loaded with aviation fuel. Kerosene will burn. Now next question is, what about wax? Yes, wax is solid, but wax does convert itself into liquid very quickly. And once it Which one? Paraffin is not petrol. Paraffin is wax. Petrol is a different thing. Petrol is with which you run your cars. So paraffin is solid. Paraffin converts itself into liquid, and the liquid also further vaporizes. Now the question arises, will the nail polish remover catch fire? Very badly. You're not supposed to use that nail polish remover ever in kitchen. Never take perfumes, deo sprays in kitchen, because all these deo sprays are highly flammable. Even the Mortine or the HIT that you have, which you used to spray on mosquitoes and cockroaches, they're nothing but kerosene. They have got kerosene. Their main ingredient is kerosene. If you actually spray Mortine, it will immediately catch fire. Be very careful when you're using this things in kitchen. Yeah, flame logo. We call it highly flammable. Deo sprays, highly flammable. Any perfume, highly flammable. So now our question comes. Huh? Volatile substance is any substance which changes into vapor. So now our question is, instead of volatile substance, if this substance is, say, suppose combustible, try to understand, if this substance is combustible and it is equally volatile, that means will it give a flame? 100%. Let's ask ourselves, kerosene, is it combustible? Yes. Is it volatile? Yes. Kerosene, if you keep it open, it will not run away as vapor. But if we heat kerosene, immediately it will get into vapor. That's why we use it in lamps. Petrol, when you fill fuel in your car, it's a very foolish practice to fill fuel in the midday, because midday the car is very hot. And if you're pouring fuel into it, and if you're buying, say, 50 liters of fuel, at least 3 liters something will go away as vapor, because the car fuel tank is very, very hot. So when should you always fill your car? Early morning. Early morning, the car is cold. At that time, at night time also, means temperature should be down. Car should also be cool. Even in summers, if you go at night. So if it is raining and all, and you go and fill fuel, you will not lose fuel. Sometimes, I don't know, if you have seen that, suppose you go to a fuel station and they are filling up the car, and you stand a little bit distance from there and look into the nozzle, you will see some atmospheric refraction, we call it. You'll see as if some mirage sort of things can be seen. What is that thing which is trembling? Is the fuel vapor which is coming out. The petrol which you have bought with your money is not going into your car. It is going outside. At that time, if you ignite it, it will catch flame. Are we fine now? So which all substances give you flame? Flames can be given by substances which are combustible and equally which are volatile. Now we come to see gases. Question does not arise. All gases are already in vapor state. Let's come down to liquids. If those liquids vaporize, they will give me flame. All liquid fuels will burn with flame. So when they ask you that give examples of 2 or 3 fuels or 3 substances which burn with flame, you first don't try to think of substances. First try to think anything gaseous gives me flame. The teacher says, tell me some more things which burn with flame. Then the next thing should be, let's think about some liquids. Diesel burns with flame. Petrol burns with flame. Kerosene burns with flame. Aviation turbine fuel burns with flame. Lubricating oil burns with flame. Mustard oil, not immediately mustard oil will catch, but with mustard oil also you can light diyas and there is a flame. All cooking oils will burn with flame. Obviously, their temperature has to be raised. Now we come down to solids. Let's think about some solids. Paraffin burns with camphor. During the puja thali, we always have camphor in it. Right? In every arti that you do, you have got a camphor which will be burning. Catches. But there are some, like if you take this table and you take a piece of wood, small wood, it will catch flame for some time, but whether it will sustain or not, we don't know. Okay? Is this much clear? Yes.
If a substance is not volatile, so
it will glow. Yeah. Coal is not volatile. See, I'll tell you, coal is combustible? Yes, very combustible. Is coal volatile? No. So coal will not burn with flame. If you see the guy ironing with coal and he just lifts his iron, you'll see red color glowing coal on that. Don't go and touch it because it will kiss you very badly.
The thing that the coal doesn't vapor. Sir, why does the fire pop?
Why does the fire?
The glow. why does the heating stop?
Heating, I didn't get your question.
Combustion.
The combustion doesn't stop in coal. Who says the combustion stop? Doesn't stop. We are making barbecues and we are making rumali rotis, we are making naan, tandoori chicken. How are you making all these things? They've got a big tandoor. Inside the tandoor, coal is kept. No, it doesn't stop. It will burn. The glow goes away because you get a layer of carbon. At that time, if you are if you are at a beach where people are selling those roasted corns, they will just use a fan. Once you fan it up, the ash layer goes away. See, if it is a solid thing which is burning with a glow, there's an ash layer which is forming on it. So you think that it is not burning. Aisa nahi hai. After that, if you just dust it for some time, again you'll see the red glow coming up.
For example, for a long time. After that, it just turns into.
It just turns because the fuel is over. The burning component is what? Carbon. Entire carbon has been converted to carbon dioxide. And what you are left with is impurities now. It will not burn. No, it's not vaporizing. Carbon dioxide is a gas which is the output of combustion. The substance should vaporize. Then only it will catch a flame. Otherwise, it will burn with a glow. What is coal gas? What did you do in coal and in the chapter of coal and petroleum? That coal gas has nothing to do here. Are we fine on this? So now our next job should be to understand structure of flame and some characteristics of flame. Let's understand these. Characteristics of flame. Okay, let's see characteristics of flame. Now, since we have understood what is a flame, right? Flame. So what is flame? Region where vapors of combustible substance exist. So this is my flames definition, right? Now we will see this flame we see of two types. You see a blue flame and you can also see yellow, we call it yellow, or sometimes orange sort of a flame. Okay, and if you are unable to identify a yellow flame or an orange sort of flame, let me give you an example. If you see the LPG flame in your kitchen, suppose something is being cooked, and turn off all the lights in your kitchen, you will see beautiful blue color flame out there. That's a blue flame, right? And when you're burning a candle or you're burning a lamp, at that time, what sort of flame we see? A yellow flame or an orange flame. Now the question arises, what is the difference between these two? Always remember, a blue flame comes when complete combustion is taking place. Complete combustion means the fuel is burning fully. Complete combustion. And for complete combustion to take place, you should have sufficient oxygen. Sufficient oxygen, because oxygen is your supporter of combustion, doesn't burn. Now here also we need to understand a story. Look, do we have oxygen in the air right now? Yes, around 20% oxygen. Now when you see a fuel like LPG, for LPG, 20% oxygen, like in the atmosphere, how much oxygen we have? 20%. 20% oxygen, or the oxygen in the room, is sufficient oxygen for LPG. Are you getting it? So LPG burns with what? Absolutely blue flame. Things which do not burn with blue flame are actually undergoing what? Incomplete combustion. They are undergoing incomplete combustion, and here there is insufficient oxygen. Now you may ask a question, sir, the environment is the same. Nobody came here and used a syringe and took away the oxygen. No, it's not like that. The environment's oxygen for this particular case may not be sufficient. Are you understanding? In these cases, you will get yellow flame. Another, in higher classes, you will also learn something called sooty flame. You know what is a sooty flame? Have you seen some very badly burning lamps and all, which will burn with a black flame, black soot, you know, like when that Aladdin's magic lamp and all, that soot comes out, right? Soot is something like a black smoke. You do have a flame, but a soot is coming out. Usually, soot comes out when you are cooking in villages using firewood and all. That's why, to prevent the utensils from getting damaged with soot, what do? We take the utensil and we coat it with mud, and then only they are used for cooking. Nahi to, like in Hindi we say kali gir jata hai, black aa jayega. That's called a soot. However, the soot can be used to do some very good things. Suppose you want to make kajal, you know, kajal that you put in your eyes. The best way to make kajal is take a plantain leaf, small piece, and grease it with oil, and use the plantain leaf and get it heated just on its surface on a small diya when the puja is happening. At that time, you'll see some soot coming out, and the plantain leaf will develop a black oily substance. That is the purest form of kajal. Kajal is nothing but carbon. You can take it and immediately put it in your eyes. That is purest form of kajal. Are you getting it? Soot. So the sooty flame also comes when there is insufficient oxygen. So let me give you an example. I don't know how many of you know, but in higher classes you will understand. There is a gas whom we call as acetylene. Acetylene, okay. Acetylene is a gas which is used in gas welding. So if you see gas welding, the trolley of a gas welding guy will actually have two cylinders on it. There will be an acetylene cylinder and there will be an oxygen cylinder. Right? It's raining? Yeah. Just check whether you're getting water out here. Any water has come? Not yet? Then don't close it. Huh? No, there it will not disturb you. Just check here. I'm saying to show. So, no, not that. The Sharvesh, he is fine. So we have a gas called acetylene. This is very interesting. When you see these train accidents and other thing happens and the bogies topple over, at that time you can't expect the door to open, but you have to rip apart the bogie. So you'll always hear gas cutting people have reached the site, gas cutters. So they will have a torch in their hand and a gas flame will come out from their hand, from that torch. And that flame is so strong that if you put it across the compartment, it will rip apart and you can cut it into two pieces. Now, well, how does that gas work? The gas which is responsible for this gas has very high calorific value, acetylene, huge heat. But the problem is that if you burn it in atmosphere, this is like LPG, it will burn absolutely with a sooty flame. They will say the moment you start igniting it, it will make a noise like this, boom, and black soots will come out. Hardly some orange, very dirty color flame will come. So the torch actually has two hoses. One hose goes to the acetylene cylinder, the other hose goes to the oxygen cylinder. So first he will switch on the acetylene valve and ignite it, and you will see boom, some red flame coming up. Then he will open the oxygen cylinder. Once he opens the oxygen cylinder, this flame will come out with a sharp blue jet. Fast sound, and it will make this edge absolutely sharp. You can see the flame like a sharp thing, like a needle. And then even that is used by goldsmiths also sometimes. That time, the amount of heat that it will produce. Now the flame will turn absolutely blue. Blue means complete combustion, sufficient oxygen. So what do we get to know? Atmospheric oxygen was not sufficient for acetylene. So what did we do? We provided additional oxygen to it. In higher classes, we call it as lancing. We have lanced it with oxygen. Now it is undergoing complete combustion. Now the flame that you will get will be blue in color and it will have huge heat capacity. That sort of a system in grade 10 you will learn. We call it as an oxyacetylene system. Alone acetylene does not make any wonders. But with acetylene, if you supply it with oxygen, double wonders. Ship industries, where all old ships come and have to cut those ships, they don't use acetylene. It is costly. What they use instead of acetylene, you know? LPG. LPG cylinder. LPG burns with a blue flame, but the flame that is coming out from your gas stove is not sufficient to cut an iron grill. So what they will do is they'll supply additional oxygen. That's the same thing that the village lady also does by using the pipe and blowing when you're cooking something. Have you seen? When you blow with a pipe, the fire increases. Why? Because what you're blowing air. Air contains oxygen. Here we are using pure form of oxygen. You're burning, we are giving you extra oxygen, like iron. For iron to melt, you can't expect iron to melt only by LPG and all. We have to supply additional oxygen. Not LPG, acetylene is a different gas. It's also a hydrocarbon, but it's a different gas. It's a petroleum product, but not LPG. And acetylene, when it burns, acetylene, now you can ask me a better question. Sir, if I mix acetylene and oxygen, can I use it for cooking? Oh, no, not at all. In cooking, you need this much heat. This one will produce bomboride. Pura kadhai aapka melt ho jayega. Your entire vessel will melt out. Have you understood? So, are you getting this idea between blue flame and yellow flame? So let's revise. Where do you get a blue flame? We get blue flame when the substance or the fuel undergoes complete combustion in sufficient oxygen. Sometimes the atmospheric oxygen may be sufficient. For example, LPG, CNG, in these cases, the atmospheric oxygen is sufficient. And sometimes we may have insufficient oxygen. Like say, we are using acetylene and we want to burn it here. It will not burn with a blue flame. Now think yourself, have you seen in villages this sort of we have studied with these, the lamps which are the lamps like this. Have you seen it? There's a flame. The kerosene lamps. Okay, in this kerosene lamp, this portion, the glass portion, we call it the chimney. You can take it out and we used to clean it. In our hostel days, we used to have it. Like when power goes away for 3 or 4 hours, then you need to study. Okay, so you have a base, something like an ink bottle, sort of a glass bottle, and there it will be filled up with kerosene, and a wick will be dipped here. There is a wick which is dipped here. So what happens? The wick keeps on sucking kerosene, right? Kerosene being volatile slowly rises up the wick and the whole wick becomes wet. Now when you light a matchstick and you bring it to the wick, you feel the wick is burning. No, if the wick burns, then in one day the whole wick should go away. The wick doesn't burn, it's flame. So what is burning? The gaseous portion of the kerosene is burning. And you will see the wick has to be replaced, but not today or tomorrow. At least after 3-4 months, we will be replacing the wick. Or we will be using a scissors and again polishing the edge. Wick does not burn. The wick is only being used to soak kerosene and convert that into vapor. Now, what is my job for this lamp? Do I need it to cook vegetables or do I need it to study? Study. Means what do I need from here? I'm getting energy from the fuel, but I need the energy in the form of light. Whereas here I'm using the energy more in the form of heat. In the kitchen, LPG has got very high calorific value. But if you turn off the switches, can you go and do your homework in the kitchen? No, because in kitchen, our heat component is more. And in these things, we will find that the light component is more. Now look here. Why did you put the chimney? You should ask. We put the chimney because we restricted the oxygen in and around it to come and reach to the fuel. So you deliberately created insufficient oxygen. Maza aa raha hai? So what will happen? This will now start burning with yellow flame. And that is what I want. I want light. 3 diyas together is sufficient for me to write a letter. But they're not sufficient to make a cup of tea. Are you getting it? Is it getting clear now? So a lot of things we have understood. Let us just summarize them. So when we talk about a flame, we can get, come on children, you tell me, you can get a yellow flame or you can get a blue flame. The flame is coming from a fuel that you are burning. So obviously energy is there. And this energy is getting in this, the energy is more in the form of light. Here it is more in the form of heat. Here we have oxygen. I'm writing oxygen as O2. I hope you understand. Here oxygen will always be sufficient. There is no shortage. Here oxygen will be insufficient. Okay, here oxygen. See, this is the way how you learn. It's not about mugging up. Get the process clear. Insufficient. If the oxygen is sufficient, in this case, we expect complete combustion. Yes or no? The fuel will burn, खुशी से जलेगा, with all happiness it will burn. And here we expect to have incomplete combustion. Fantastic. Mishka, have you understood now what is the entire story of flame? Flame will always come in those substances which have vaporized, and there is a vapor portion, and in that vapor portion the flame can be yellow or the flame can be blue. Blue flames are usually seen for those substances which do vaporize, which are combustible and burn happily completely in sufficient oxygen. Sometimes some things burn in yellow, but if you apply or supply additional oxygen, they turn into blue, oxyacetylene gas. Right? Even in blast furnaces, diesel, diesel will catch a fire which will be flame, which will be yellowish in color. Diesel catches a yellow flame. But when you supply more oxygen to diesel, diesel's flame will go blue. Have you understood? That's what, obviously. Complete combustion means you have money in your pocket. You are not spending completely. If you spend completely, then only we will get more returns from your money, right? So you look at the aviation fuel. Now this tragedy happened. Now the flames that you are seeing are what flames? All yellow flames. That means that fuel, right now the way you are seeing it burning is not complete combustion. But what happens in an aeroplane's engine? That's a gas, that's a turbine. That's a ram turbine. And in that turbine, huge air will be sucked inside. So the fuel will be what in color? Blue. If you see a Sukhoi aircraft taking over, a Sukhoi aircraft, if you see the backside, and when they just turn on the engines of fighter aircraft, the blue jets you can see. That's complete combustion. But that combustion was not complete when the fighter plane was just idling or taxiing. And when he says, Roger, ready to go, and he just pushes all engines into full thrust, you will see the blue flame coming up. At that time, what has he done? He is supplying more oxygen to the fuel. So the fuel is now burning with complete combustion. Blue flame, heat. I need energy. You don't need to do your homework behind a Sukhoi or a Rafale or whatever aircraft it is. I hope you understand now. So let's now see one very beautiful diagram, zones of flame. Okay, so our next topic is, and the last topic for today on the chapter, zones of flame. So let's make one nice birthday candle. So this is the birthday candle. Understood? And then we have a wick. So let's see how the flame looks like. So a flame has got 3 zones. The outermost zone will always be blue in color. Okay, that's the outer zone. Blue means complete combustion. So what about the temperature? Should be hot. Should be hot. Inside the blue zone, what we will get? We'll get a yellow zone. What is happening? Medium combustion is taking place. Temperature will be moderate. And absolutely at the center, what we will get is unburned carbon particles. Black zone. The wick. So let's see how many zones the flame has. The flame has 3 zones. The outermost zone. This zone is known as the outermost zone. Outermost. And here what is happening? Complete combustion. What is the color you expect it to happen out here? Blue. Then which zone do you have? The intermediate zone, or we call it the middle zone. This question is very common in schools. They'll ask you to draw a neat level diagram and explain the zones. So we have the first zone, we have the middle zone. This will be either yellow, or it will be yellow, dirty fellow, or slightly orangish, okay, yellow or orange. This is incomplete combustion. This is incomplete combustion, and this zone will be the hottest zone. This will be moderately hot. And then last we have the third zone. This is zone 3. This is the unburnt or carbon deposit zone. And here it is the coolest zone. Have you seen some people when they burn candle and they show some ustadi by putting their finger on the candle? So it's very easy. If you're putting your finger out here, you ask him to keep the finger very near to the flame. He will not do that because this zone is hot. And when you go inside, it is actually very cold. Many people even shut off the candle with their fingers. They show as if they have got a lot of tolerance. It's nothing like that. That is the coldest zone. If you ask somebody to get the punch from the flame, ask him to put the hand here. That he'll not do. Because this zone is the sharp zone of the blue zone. This will be very hot. Okay? So draw this diagram and make a practice to have this diagram properly drawn, because this is what people will be asking. The schools will have this. That is the least hot zone. And so this is called outermost, this is called middle, and this is also known as the innermost. Yeah, one by one. Yeah, tell me. So these 5 zones, no issues. You keep 5 zones with you. So as long as you read and as long as you understand. The three prominent zones are the outermost zone, the middle zone, and the innermost zone. What we need to understand here is, in outermost zone, complete combustion is taking place. You'll see a blue color, sufficient oxygen. Innermost, incomplete combustion is taking place. That's why you see yellow color or orange color. And the middle zone, the innermost will always have a black color, because there you all have is residue of the unburnt carbon particles, and that will be the coolest zone as compared to all. नहीं कर पाएगा ना. You can never try that also. The LPG flame is all blue. All blue means superb combustion is taking place. Huge energy. Blue means energy in the form of heat. So why are you going and touching that? In fact, I don't know, if you are habituated to cooking sometimes and you move your hand too much near the gas stove, you'll suddenly find a very pungent smell coming, because the body hairs are there, na? They also sometimes burn out. You won't feel the burning part. Like if you just move your hand nearby to the gas stove at that time, and then you just start smelling, you'll see a burnt smell coming up on your wrist. There will be no heat or nothing. You won't realize. But that burnt smell is actually giving you a indication that some sort of body hairs have got burnt. That much is the heat. In fact, in hot summer days, if you have got kitchen paper towels or tissues, which are absolutely what we call crystal dry, and you keep them too near the flame, they catch fire. See, it's like this. I'm wearing a cotton t-shirt. Now this is 100% cotton. His t-shirt is 100% cotton. What is the oxygen in the atmosphere right now? 20%. If you increase the oxygen to 40%, this cotton t-shirt immediately will catch fire. You don't need to burn it at all. Well, supporter, you're enriching the environment. That's what we said, na? The ignition temperature depends upon the oxygen's concentration also. If oxygen is less, suppose we have a zone which is depleted of oxygen, even if you take out sodium, what happens? Nothing will happen. Take out sodium outside space, nothing will happen to sodium, because you don't have oxygen. Now you are giving more oxygen. At that time, the room temperature reaches its ignition temperature, because you are creating a enriched zone. Tick. Is flame clear? There is a last and final portion which says that burning of fuels leads to harmful products. So let us discuss. This is a very open-ended question. Okay. Burning of fuel leads to harmful products. Now let's discuss. If you burn more of fossil fuels, right? So we go to the next section and we say, suppose we have a choice of burning fossil fuels. What are fossil fuels? You tell me. Coal. Then we can have the ones which we are using very much, petrol. Then we are using diesel. Then we are using, LPG. We are using natural gas. And there we are using kerosene also. Okay? Let's take these. And let's take candle also, or paraffin, or say wax. Okay, wax. Now let's see what all harmful things. Any fossil fuel that you burn, the one thing you're going to get from all is carbon dioxide. What is the harmful effect of carbon dioxide? It creates more heat into the atmosphere. So this is your earth. So across the earth, what is happening? The carbon dioxide, being a heavy gas, encircles the earth. Now in the daytime, what is happening? The sun is actually heating the earth, right? You're heating the earth. The earth should also radiate the heat back. Once it radiates the heat back, this heat is unable to get into the atmosphere. As a result, the heat remains within the earth. So the earth's temperature goes up. What is the bad part of it? There'll be global warming, ice caps will melt, right? Then you'll see floodings happening. But there's a good part of it also. The only good part of global warming is Iceland and Greenland increases their tourism because they are always in ice. So you get a weather, global warming is helpful for them. But if you see in Bombay, the water level is slowly climbing up. Have you understood? So CO2 everyone will give. Now let us look at coal. Coal will give me CO2. It will also give me, I am writing SOx. SOx means oxides of sulfur. Highly bad. And depending upon the type of coal, you may also get carbon monoxide. These two are very cancerous. When you burn these two, you are going to get COX. COX means oxides of carbon, like carbon dioxide. Oxide can be, a COX can be a CO2 or a CO. CO2 is carbon dioxide, carbon monoxide. Then what all we are going to get here? SOx. And we will also get NOx. NOx is oxides of nitrogen, oxides of sulfur, oxides of carbon. So what is happening? Since you're using more of fuel, you are having in this region SOx, COX and NOx. Do you agree? All these three gases, ये जो auto के पीछे से आते रहता है ना, these are the gases. The bad part is when it starts to rain, these gases are coming in contact with the falling water. So this will become sulfurous acid, carbonic acid, nitrous acid, and nitric acid. So in Bombay, or say any polluted city, like say if you're going to a very polluted city and the first rain comes, and if you're wearing white shirt, your white shirt will have yellow patches. That's nothing but the acid that has fallen. So in these summers, when the first rain happens, do not go and get wet. You're not getting wet under rain. You're getting wet under acid rain. When it rains for 3-4 days and you've ensured this is washed off, ab jaake bhigo. That's the reason the area around Taj Mahal does not have any industry. You're not allowed. Taj Mahal, do you know, is a no-fly zone. No aircraft can fly over Taj Mahal. Why? Because the aircraft will release SOx, COX and NOx. They will remain suspended and acid rain will damage the marble of Taj Mahal. You'll get yellow color in Taj Mahal's marble. Got it? So if I look at LPG, one of the cleanest fuel, this is going to give me only CO2. Natural gas gives me only CO2. That's why when natural gas has been converted to CNG, it's a lovely fuel in Mumbai and Delhi for transportation. You don't, see the good part in CNG vehicles are, you don't get SOx, COX and NOx. SOx and NOx, you'll only get CO2. And CO2 is not bad for your health. Carbon dioxide is not bad for my health. Carbon dioxide's only bad thing is it is increasing temperature. But when sulfur dioxide and nitrous oxide comes, they are cancerous for us. You are not realizing it also. Many people think that I'm eating this has got calories. When you go in an auto, you are damaging yourself much more by inhaling the exhaust of that truck in front of you. That's why pollution control should be very strict. A person not wearing helmet, fine him. No license, fine him. But if his exhaust is emitting harmful gases, stop him and fine him 9 times. You have every right to die, but no right to kill others, which our people don't realize. Our people think, hey, धुआं थोड़ा निकलना कोई बड़ी बात नहीं. Every auto you'll see there's an exit. Never tailgate that vehicle. You're just simply damaging yourself. Have you understood? So it's like smoking cigarettes only. Now, if you look at kerosene, yes, in kerosene also we will get CO2 and we expect some SOx and NOx also. Wax is usually CO2. You don't expect. So if you are burning fuel, what is the harmful effect? The first harmful effect is release of gases which are harmful to health. What are these gases? Oxides of carbon, oxides of sulfur, and oxides of nitrogen. ये 11-12 तक यही terms use करते हैं. SOx, COX, NOx. You should remember that oxides of sulfur, oxides of carbon, and oxides of nitrogen. When gas and rainwater falls on it, this become acidic. Okay. Now this is done. Carbon dioxide. So they have made this into 3 points. I've given them in 1 point. This says that burning of fuel produces unburned carbon particles. carbon products, then sulfur dioxide gas. CNG is a clean fuel. Does CNG have any emission? Yes. CO2. Not so bad. That's why people say migrate to CNG. Does LPG have any emission? Yes. CO2, but not SO3, SO2, these don't come out. NO2, NO3, these don't come out. Those are very harmful. And if you are burning too much of fossil fuel, you are also going for deforestation. So what is the solution? People say go electric. But in go electric, we have got two concepts. Are you green electric or are you gray electric? You know what is gray and green? Green electric, no. Green electric means an electric vehicle runs on what? Battery. How did you manufacture that battery? Did you manufacture it in a plant in which you used fossil fuels, or you used electricity and that electricity was generated from coal? Then the vehicle that you are having, electric vehicle, is not fully green, it's gray. Green means, that's why now people are saying switch on to hydrogen powered vehicles. Now hydrogen can come in two ways. One is you get hydrogen naturally from bamboo. Bamboo is a very interesting fuel that is being developed. It's completely green. But if you are getting hydrogen from electrolysis, to do electrolysis you also need current. Then that current inside the moving bus is coming from where? The battery. How did you manufacture the battery? Battery cannot be manufactured in a plant where there is no electricity. Then the next question is, how did that electricity come? Sir, my electricity comes in my factory from nuclear power plants. Yes. Then there is less of exhaust. You can consider you to be a little bit green. Otherwise, you're solar powered. Then it can be green. तो ये जो लेक्चर हम मारते रहते हैं ना, ग्रीन ग्रीन ग्रीन, वो पूरा ग्रीन नहीं है. Green is only when it is in the vehicle. But how did it get fitted in the vehicle? From a gray process. So burning of fuels, one is pollution, atmospheric pollution. What is pollution? Deterioration of the quality of the environment due to man-made practices that causes difficulty in your medical conditions. Your livelihood is known as pollution. Are we fine? Now these pollutions are the various oxides that you saw, and also deforestation. So what should we do for it? Every morning go to the bus stand with different scooters and Activa, and then when painting and drawing competition comes, then make those paintings and put it on titanium lobby. Mother Earth, save it. We only planet, care and share. And next day morning, all children are being taken to bus stand in scooters. So that is called eye wash. Don't do eye wash. Right. So we conclude here then.